Hi everyone, this is Chris Ling, Business Development Manager for Systems at Jands. Welcome to this Ampetronic 101 webinar, looking at Loopworks Design. And I'll introduce our presenter today. It's Jacob Mumford. He's from our Application Engineering and Training team and actually undertakes the in-class Ampetronic installer training for us. Say good day,
Hey guys,
Jacob.
how you going? Good to have you guys here. Should be a good little session. Yeah.
Excellent. Just waiting for a few more people to join us. Just to go through some formalities for you all. On the right-hand side, you can ask questions at any point in time. Feel free to click the icon to raise your hand as well. We can answer any questions that you have via that question function on the right-hand side. If there's anything that we may already address in the course of the training, we'll keep a note of that. And if there's anything we haven't answered during the course of the webinar, I'll make sure we come back to it towards the end. So we'll just give it another couple of minutes.
And Chris, if you wanted to pass over the presenter rights to me,
yep,
I can share my screen.
All right, so Jacob's got the holding screen up and ready to go.
Cool. So you guys should be able to see my main screen now.
Excellent.
Yeah, just while we're waiting, generally pretty informal, as Chris said, during these webinars. If anyone does have any questions, feel free to raise their hands, and we can unmute them, and then they can ask an audio question. Or if you don't want to do that, you can put through a chat question down the bottom there. So yeah, feel free to ask any questions if we don't answer everything along the way. Yeah.
Okay, so we're just waiting to see if a few more people will join us. So there's a question already. The recording will be available afterwards, so you can use your same login and watch back the entire webinar in video recording. You can share it with other people as well. Yep. I hope that helps, Chris. Yeah. Excellent.
I would still advise watching now. Don't log off straight away.
So I might just get a quick show of hands or in the chat or questions. How many people have been attending a lot of webinars recently? Feel free to just put your hand up or say me in the chat or in the questions. Trying to avoid awkward silence.
I assume we've all been at home for quite a while now, and I'm sure people are getting to their limit of webinars, but there's still plenty of good information out there, so we're trying to do our fair share, of course.
I might just see by way of the chat as well, all the questions. Feel free to put down what role you perform in your organization and where your interests lie with Ampetronic Loopworks. If you're just curious about it, if you install it, if you specify it, that'd be great.
Okay, cool. Should we get started now, Chris?
Yep, let's go for it. All right, hand over to you.
All right, thanks, Chris. Yeah, so you guys who are here today are obviously here to talk about or learn about Ampetronic Loopworks, specifically their design module. Now, Loopworks is Ampetronic's online portal. It basically houses their design software and their measure software, or the results that you get when using the app. But we'll specifically be talking about design today. So one of the first things that we want to do is we can create an account. You can see I'm logged into my account at the moment. It's not housed on the Ampetronic website. It's actually loopworks.ampetronic.co. So if we go to that, I'll just take you to the main page. We can see we've got a few different options here to choose from. So the main two that I generally sit within are the measure or the design. They'll actually both take you to the same place. So it doesn't actually matter which one you click on to begin with. So I'll click on design there. And that will take us straight into our main page that we'll be sitting within. So we've got a few things that we can see straight off the bat. we've got projects, our designs, and our measurement, which we'll talk about a little bit. Now, what you see here may vary, and what you're able to do with inside the design software may vary slightly. There's a few different access levels. So to begin with, we've got the lowest access level, which is the commissioner. It's basically the person that is going to be, learning via that Learn tab that we saw a moment ago, as well as giving you access to Measure, which is the Measure app. If you want to do commissioning or site assessment tests to begin with, you would be a commissioner level. It won't give you access to designs, but it's more for the guys with their boots on the ground out there doing the install and things like that. Next, we have the estimator, which gives you access, or is the first level of access for the design tool. You basically can do simple designs. We don't get to see things like the loop layout, which I'll show you a little bit later, but that's basically what you would install off of. So as an estimator, you can do, it's basically what it says, right? You put in a few designs, you basically see what you're getting out, but you wouldn't be able to build off of that. The next level we have is designer, who will have experience through estimator and will actually be doing designs and can print full report PDFs. It gives you the access to the loop layout, so you can build off of those designs as well. Then we get up to the specialist, which is someone that can import CAD designs. So when we start to get a bit more specialized in terms of like maybe rail or concourse areas, or some floor plans that aren't necessarily a rectangle or a square, and we need to import a CAD design that we've got, that's what level we're looking at there. So there's a few different options you can have, but we'll go through that as we start to go through today as well. So in terms of file structure, it's pretty important to get this right from the beginning. We need to make sure we get it right so that later on we don't get bitten when we want to sort of move files around and things like that, and we can't do it. So I'll sort of take you through best practices for the moment. So we're inside of our projects. We can create new clients if need be. For the majority of today, I'm going to be using Jands just as our main client, but you'd fill in your client's name, you'd have some contact details and their location, and then this is where we start to get into creating designs for specific clients. So we can see inside of my projects tab, I've got one that I currently use for the Ampetronic installer training because I host that for Jands. But you can see your recent projects, your company projects, so that's any designs that someone's done inside of your company. And then if you wanted to see some archive projects that you'd done a few years ago, you can go back to those. So we want to create a new project. We want to basically have the structure of a project which will be a building or a venue. So say there's a new building going up in Sydney. It would be the building, which is the project, and then any rooms that are inside of that building that need loops, they would be systems. So we'll look at that in a second. But basically for now, what I'm going to do is I'm going to set up my project, and I'm going to call it, say we would have a company name to begin with, and then we'll say it's their Sydney office. Okay, so that's my project. Location, I can just say it's in the CBD or wherever. Our client, I'm just going to say is Jands for the moment because I don't want to create a specific client for this. Owner is the person who's creating this. So as you can see, we've got a few different users inside of here. I'm going to assign it to myself. Units of measurement are pretty important. Obviously in Australia, we're working to metric. So we can look at the defaults as well. You can actually change a few things within here and the design itself for the defaults, but we're majority working in metric. Ampetronic reference, if I just move this out of the way, you can see we've got a reference number here. Those are the reference numbers that Ampetronic use to keep a catalog of all the designs. You could have your own project reference if you wanted to. I've had one there previously, but we could just say, it's design 152. And then if the specific client has a project reference as well, you could put that in there. Now the company,
I might just say that, I might just jump in for a sec there, Jacob. That client project reference or your project reference is really handy when you're responding to tenders, because it also helps, especially if you're letting us know about the project design that you might be working on. We can see what people are doing for potentially the same tender and make sure people are on track as well.
Yeah, thanks for that, Chris, 100%. And then the company there is the company that, your company essentially that it's under. Now, a pretty important one dealing with Australia, I believe we're the only country that has one of these checkboxes here. Adopt the Australian standards. So that's talking about AS 1428.5 or AS 1428 in general. That gives us a bit more tolerance when it comes to metal, because basically every building we have here in Australia has metal in it. So we do get a slight tolerance for our standards, which is good. So I'm going to click that on just so that we can make sure we're working to our standards here. So I'm going to hit add. And we can see that it's created the project. So I've got a project there. We can see I've got 0 systems at the moment, and we can see when it was last active or last viewed. Now, some important things that we might want to change before we get into working in here is if I go into my settings, I've got a few different settings we can change. There's that metric and imperial setting that I had before. Here's the option for the Australian standard. So if you want to be able to have that appear in your project settings, then that's where you would select that. And then we can also change our logo, which becomes important when you're putting designs out later on. You want to make sure you've got the end person knows who it's coming from. So if we go back to our projects, go into my project that I've just created, and we can see here I've got a list of systems. So this would essentially be the list of rooms that I'm doing loops for. I currently have none there because it's a brand new session, but I'm going to create a new system. I'm going to call it something like, maybe it's a large meeting space. And maybe it's O1. It's a system type, so area or service point. Area would be for a space that we're trying to address, whereas service point would be maybe where someone's being screened from the public. So, buying a train ticket or something like that. That's where we'd have a counter loop. Now I can put something in there for the description if I want. So I can say 1 of 10 large meeting spaces, just so I know that I've got another 9 to come. There we go, and we can see that that's appeared there. I've currently got 0 designs and 0 test sessions. That's to do with measure, but we'll come back to that in a bit. So if I go into my system, we can see it brings me straight into measurement. The reason for that is if it's, say, a retrofit or even a new build that hasn't had the loop installed yet, you can go in and you can do a site assessment test with your Loopworks Measure R1, which pairs with an iOS device. So that would basically give you an example of what sort of metal you're dealing with in a space and help you in your design phase. So that's why it takes us to that first. So if I go to my design here, I can go new design, and I can go, I want to call it A-field design underscore V1. All right, so if I start to have different versions, they will start to populate here. But what it does is it takes us straight into our system that we've just created. Sometimes it does take a little bit to configure itself straight off the bat because we are working off a web GUI. I assume it's going back to Ampetronic servers, so we do have a little bit of delay there. I'm just going to go back out for the moment. We can see inside of our designs, we can see I've got my version 1. I can have as many different designs as I like, but I can only, you can see it's in draft status at the moment. I can only publish one of those and issue one of those designs. I can have as many designs as I like, as long as they're in draft state. So if I go into this A-field design version 1, we can see some of our project information to begin with. The information that we've already input down the left-hand side here, as well as some of the naming and things like that. I'll just let it do its thing again. This is also, if we had, say, large meeting space O1 as another system, this is also where we can save basically this as a template to something else. So if I hit save new here, we can see I can choose another meeting space if I had another one selected there, or I can basically go to a different project name, see all the projects we've got there. So it's pretty handy to know. System quality, a lot of people ask questions about this. generally what we're talking about here is what sort of level or what sort of dynamics of input we're going to have, and that will basically affect what's happening in the output. So if we select normal mixed content, we're sort of looking at a teaching space or a meeting room where it's just going to be speech the whole time. Looking at transient speech, we're looking at sort of counters or information points, maybe a concourse area. And then music performance is obviously like your theaters or your venues where you're going to have a lot of dynamic content. That's very important because it starts to talk about voltage headroom and current and things like that. So most of the time you're going to be picking normal mixed content. That's why it defaults to that. So we're going to go down to our design tab straight off the bat here. We can see the defaults that are populating. So basically I'm going to stick with a room that's, well, as for this example, I'm going to stick with a room that's 15 meters by 10 meters. You can see that's our X and our Y. We can get a bit more into that in our outputs. Our loop height is basically where the loop's going to be sitting. So, 95% of the time we're looking at loops that are floor level. So I'm gonna leave that at 0. Listening height is the height of the telecoil in the hearing aid. So being a meeting space, I'm going to say that the seats don't move around a lot. So majority of the time people are going to be sitting. So I'm going to do my listening height to 1.2. Generally the max you do is 1.7 for someone that's standing, and maybe like 1.4 for maybe children or something like that. Really depends. So gap to room edge is talking about, we've got a room that's 15 by 10. If we had this set to 0, essentially the loop would have to be underneath the wall, basically right on the perimeter of the wall. We set an offset of 20 centimeters or 200 mil, which basically brings it in the room a little bit, just makes it easier for installation. So talking about metal structure, this one's very important. It plays back into our Australian standards. At the moment, I've got that there's no metal structure. We can see all the options that we have. These all have varying values. So if you're taking an estimate or a guess as to what sort of steel we've got in a place, this is where we choose. If we know, so if we previously did a site assessment with our Measure app, we could give it a specific metal loss, which would be really helpful in making sure we get the correct values on our outputs. For the moment though, we're actually going to choose a perimeter loop. So we can do a basic perimeter loop as an example. That doesn't actually allow us to choose those options. We can put a manual loss figure in there if we like, but most of the time with the perimeter loop, you're looking at a small area, so we generally probably wouldn't need that. We can see our configuration, number of turns. So single turn is 1 turn around the room. I don't actually think this graphic changes. No, it doesn't. So double turn would be looping around the room twice. That can essentially, at a small cost to our voltage headroom, that can essentially get us a better current, but we can talk about that a bit later if need be. So looking at our cables now, by default, this selects the flat copper tape 1.8 and then a feed length cable of 10 meters. Generally, we like to stick around 10 meters. So for our example, we'll say that the loop driver is maybe in the credenza of the room, something like that. And our feed cable is a twisted pair. We always deal with twisted pairs when we're talking about, a pair of single core cable, because we essentially want to minimize any noise that's being introduced onto it. And we also want to make sure that the feed cable doesn't produce its own signal. We can also change that to, we can look at something like star quad 2.5 mil, which is where we get 4 cores and we twist the pairs together. So that would be maybe the positive pair, that'd be the negative pair. But for the moment, we're going to stick with our default. Advanced tab, we might come back to that a little bit later if anyone wants to know the specific settings. But for now, I'm pretty happy with what I've put in my design tab. So I've got a perimeter loop, which is for room 15 meters by 10 meters, and we're coming in the room by about 20 centimeters. So if I hit my output tab, this might take a moment. Sometimes changing values can take a moment depending on what your internet is like as well. So we can see an overview. Our overview, is what it says. Gives us an overview of the system parameters we've already put in, gives us a design summary for what it thinks is best for the room, and then gives us an overview of the equipment and the actual physical things we're going to need to use to install this. So we can see straight off the bat, it's selected a C5-1N driver. We only need, so that one stands for one output. We only need the one output because it's a perimeter loop at the moment. So if I go down to my variation, this is where I can start, looking deeper into what the system is designed. So first thing we'll probably notice is this color graph here. This is our field strength across the area. Now, what you're seeing here is dependent on what we've put in here, as well as what we're seeing down here. Manual adjustment is probably the biggest thing that can affect what you're seeing. So if I come down, there's quite a bit of info around here, right? If I come down, I can see that in terms of IEC 60118-4, I am within my +3, -3 for almost the whole space. The center of the room is getting a bit low, so I can see if I hover over here, I'm getting down to -2.7. I sort of want to boost that up a bit, okay? So I want to get my peak maybe up to +2 with my trough in the center of the room at maybe -1. So what I can do is I can manually adjust the current on the driver. So I'm going to say, let's just go 2 dB. And we'll see if anything around here changes when I do this. If the manual adjustment basically takes more current headroom than we have available, you can see how I went from 2.2 down to 0.2. It'll bump it up to a beefier driver that's able to handle more current. So we can see this plot has changed a little bit. I'm not real happy with these peaks here. I'm sitting at 3.1. I sort of want to bring that down a little bit. Actually, before I do that, I might show you why it doesn't look like it's showing the exact same thing along the scan line. So this scan line, we can see this blue line here is dependent on the values that we put in here, right? So if I want to move this scan line along the y-axis, so I can be across these two hotspots to see what the values are on here, I would move this up to maybe, where is that? 1.6. So I'm going to say up along the y up to about 8. And I sometimes get this a little bit mucked up. It is a bit confusing to see what orientation you're in. Yeah, I can see I'm starting to get up to that 3.1 value there. So I'm not happy with that because I'm sort of going out of compliance or out of our standard. So I'm going to set that back to 5. I'm just going to bump this back down to maybe 1.5 because I think that might be a nice spot to sit in. And we can see we're still using the C5-1N. There we go. That's a lot more smoother across the space. I can sort of move my mouse across and see what sort of values we're getting. We'll look at overspill in a second. But if you do want to go into more detail, you can hit the plus and you can get a bigger image here. You can also zoom in to certain sections and you can sort of get a closer look at these areas. If you want to go back, just double click and that'll zoom you back out. You can close that window. Same with the scan line here. We have a 3D representation as well. You can use your left mouse click to drag it around to pan. We can use our right mouse click to hold and move the image, and then we can also use our scroll wheel to move in and out, so to zoom in and out. So we're going to move over to our overspill now. And this is where we start to see how much we're spilling outside of our room. So we've got a space that is, what did we say, 15 meters wide by 10 meters deep. You can see how much we're spilling over this 15 meters. So we're looking at the x-axis here. So I'm not real happy with that spill, but it doesn't really matter because we're doing a perimeter loop. I would say there would be nothing nearby, no other rooms adjacent, so we don't need to worry too much. If I want to zoom out and really see the extent, I can change this size value. So this is a multiple of the room length. So I'm just going to hit 3 and let that do its thing. And we can see now that I've zoomed out a little bit and I can see a little bit further. I'm right on the edge there. I'm getting to maybe -17 or 17 meters away from this wall down here. So that's sort of at what range did we say? -38. So we're almost sitting at our -40, which would be our noise floor level. But as I said, we're using a perimeter loop, so we're absolutely happy with that. We can see another 3D representation. Obviously the room in the center with the overspill on the outsides. We can see our null points, which can be seen in the room or right around the edge of the room. In a perimeter loop, the null points will always be on the outside of the loop. So that's just something good to know. Now, if we go to our equipment tab, this is where it starts to get interesting. We can see what the system has basically designed and why it's chosen a specific driver. Where we obviously had our loop tape specified before, but it's telling us how much tape we'll need now and how many rolls we'll need from Ampetronic. So obviously we're sitting just under 50 meters, so we could just get one 50-meter roll. We're looking at one array because it is a perimeter loop. Our estimated loss due to metal, that's set to 0 because I didn't put one back in our inputs tab. I can go back and change that if I like, but because it's perimeter loop, we're assuming there's probably no metal there. We can change our driver variant, so I can either go from a network driver if I want to a non-network driver, and then we can start to look at all the other drivers that we have available. Anything in red means that it doesn't meet the required values for the design that we'd previously specified. So C5-1 you can see is the lowest driver that we can actually use. It'll tell us things like our current headroom voltage and power headroom and our minimum impedance check. If we start to see issues with our minimum impedance check, we can start to change the cable type, because a thicker cable with more cross-sectional area is going to allow more voltage, which will basically bring down our total resistance. If we can't sit inside the total resistance for this driver, we could just decrease the cross-section of the tape that we're using or the wire that we're using. So it's something good to know. If we look at our notes section, the general install notes, I would say everybody should read these at least once just to get an idea of what's in there. People that are installing loops should probably read it every single time just to make sure they're following the guidelines of what Ampetronic says, and then any specific installation notes that you choose to put in there. If I go to the second note section, we can see some information about the feed cable, basically telling us as long as we're using feed cable twisted pair, we can insert at any point in the loop. So we wouldn't have to necessarily do it down here. We could do it up here if we wanted. As long as both the positive and the negative point of the feed cable enter in at the same point, we're good to go. Some information we can see about the loop installation arrangement. We can see that if we have a total tolerance for any dimension of 50 mil, so basically we want to be as accurate as possible, and we've only got 50 mil of tolerance to play with. Now, if we get to the building site on the day and we realize, hey, there's actually a pole in the way, or some sort of vertical structure in the way, and we can't put our loop down, we're actually, this little statement here says we're actually allowed to move 300 mils sideways, and we're allowed to deviate for 400 mils. So that's basically saying that's the most we can deviate without really impacting an array of some sort. So just keep that in mind when doing an installation or sending some guys out to do installation. So we've basically gone through all of our output tabs. The next thing to do would be to look at the loop layout. Our loop layout is pretty boring at the moment because we're talking about a perimeter loop, so it's literally just a rectangle mimicking the perimeter of the room. The segments of the array would be more interesting if we had a phased array or a low loss loop of some kind. We will look at that in a bit. I'll take you through that very quickly. We can see I've got a background image. I can upload an image, I can scale it, I can set the origin point back down to 0, 0. I can rotate it if need be. That's essentially for when the design file comes out at the end. It makes installation easier for most people, just so that they can get a representation of what's in the room and where they're actually meant to lay the cable. And then DXF, as I mentioned before, when we're talking about the specialist level of access for Loopworks Design, you'll have access to importing and exporting DXF. So we won't go through that today. That's a bit more in depth, but it's good to know that it's there. Now, reviews. Review could be maybe a senior designer comes along, has a look, and they want to leave a comment. So they could, leave a comment and say something like, "Be careful of deviating around a pole" or something like that. And you could come back in and see what sort of comments they give you about changing the design or something like that. So we can export a report now. If we hadn't put a plan view in, so we hadn't uploaded a floor plan image, I would generally take that out because that doubles up on some of the pages and people get confused sometimes. So I'm going to hit export there. It'll basically give us all the tabs that we had previously gone through, our inputs, outputs, loop layout, everything like that. It'll give us a nice condensed look inside of a PDF. And we can either hand that to someone as maybe a proposal of some type, or we can hand that to someone as an installation guide to follow along and make sure they get everything correct. So once I've exported that, I can hit Browse Reports. I can then go, we can see this is my draft design still, so I can click on that, should open a new tab. As standard PDFs, I can download or print. Gives us our basic information about the project to begin with. Tells us the company that we're doing it for. We'll put in the information of the Ampetronic reference. When we scroll down, we can start to see some good information to begin with. So we've got all the area information about the room that I input to begin with. If we had metal, it would tell us what sort of metal we're looking at. The driver specification, as I've said previously, is linked to the loop design and the cable specification. So everything that's going on inside of here and here will determine what's happening here. If we click on this PDF, it'll actually take us to the product page for Ampetronic. Just if someone's, if you've sent that PDF to someone and they want to have a look at the specifications of the driver, they can do that. But we have some basic specs there. We can see that we've got 5 amps RMS as our current value there. So if I scroll down to our next page, we can start to see the general install notes. And this is where the good stuff starts to happen. We've got our color plots, basically our 3D plots. Being a PDF, we can't move this around, but we could take a screenshot of this maybe if we wanted to send it to someone. And then we've got our coverage looking at the horizontal plane. So that's talking about our overspill a little bit there. I don't know, overspill comes up as well. Talking about our field strength. So some important things here to notice. Talking about our horizontal coverage, so the horizontal field strength at the moment, this value here to plus or negative 3 dB is talking about 60118.4. The one below it is talking about our Australian standard. So this is that tolerance that I was talking about before. We've got +3 to -9 dB. So we've got quite a bit more dynamic range that we're allowed to play with there. And that comes into effect when we've got metal or metal loss, right? So it's a pretty important thing to make sure you tick that Australian standards box at the beginning when creating the project if you do have metal in a system. We can see we're hitting 100% for our X and our Y. As I scroll down, we start to look at our overspill. It's pretty good information here as well. It will tell us our north and south, east and west at 2 meters outside the loop, how much sort of overspill we're looking at, as well as some vertical overspill. So that might be important if we're looking at meeting rooms that have vertical adjacency. If we did though, we'd probably look at some sort of phased array or some low spill or loss control, because that will definitely cut down on the spill that we're looking at. As I said before, this is pretty boring in terms of the loop layout because it is just a perimeter loop. But that information that I told you about before is written here with the install instructions. If I scroll down to the loop array, we can see the loop array again. And then the last page is the information on the feed cables. So if I wanted to install, or if I wanted to issue this design, I can basically go back into it. And we can see there's an issue design button down there. So if I had multiple drafts, but I'm happiest with this design, the client's happy with it, I would then go ahead and issue that design. If for whatever reason you do want to take it back out of being an issued design, you can come back and to this section and say, I want to make this a draft again. So that is a possibility. Now, I sort of want to briefly, do we have any questions so far in terms of looking at perimeter loops or things like that? I might give you guys just like 10 seconds to type something up.
Just while they're doing that, Jacob, do you want to talk about the benefits of what your login gives you when you're working over multiple projects, and also the network driver and how that links in with your Loopworks account?
Yeah, so talking about our actual account here, if we're looking at our projects, it makes it a lot easier to keep track of all the projects that you may be working on. Ampetronic does keep them all up here for you, so it's easy to go back and reference something. If, say, in a year or 2 years' time, when you're recommissioning a device or a system, you want to double check what the design was and you want to look at the layout, because you walk up to an auditorium, you can't see the loop in the ground, but you want to know what the layout looks like. You go back into your projects, you can see the design that was issued for that project, and you can look at the loop layout. Maybe they put an image of the floor plan, and you can actually work out where the actual loop is. Makes your life a little bit easier. Talking about networked drivers, the network drivers, the only drivers that have a network capability are the digital drivers. So basically, I would say one of the most important points that they have is you can get some fault monitoring. So if something goes wrong, you can set it up to email you, say temperature reaches max, or the driver boots on and realizes that there's no loop cable connected to it, which could essentially mean, hey, someone's cut the cable. It'll send alerts to you like that. I don't actually have a driver connected right now that I can show you, but it also gives you the ability to go into the web GUI and change the values of the driver, so our current settings and things like that, any phase settings or metal loss settings. Rather than doing it on the front panel of the unit, we can do it over the network. So we get some awesome features when we look at a network driver. It could be especially great for large systems that have plenty of drivers.
And just a question from me. Does your Loopworks login allow you to log the status of a loop when you're commissioning it? So you've got like a recording of how it was commissioned when it first goes in?
Yeah, so when you're using your Measure app, basically you can walk around a space and say there's a bit of background noise that sounds a bit unusual. You can record that, or say you want to give an example of someone talking through a microphone going through the loop, and you want to record how clear that how clear that signal is on the day that you installed it. You can do that, and basically that will come back up inside your measurement area. So if I went into, I've got lots of projects at the moment, but if I went into a specific project, I would then be able to go back and hear how it sounded on the first day that I installed it. You might have an issue later on where some sort of power distribution subplan or something like that is built next to the building, and then your background noise level goes up. You'd be able to work out what the issue is then with those recorded loops from previous. Cool.
Excellent. So we don't have any questions on the question tabs or the chats just at the moment, but it is good to see that there's some people who install loops from the attendees, and a couple of people are in sales and design as well. And understanding the process really helps you understand what you're talking to. Excuse me a moment. As a BDM and as the team at Jands, we also get a lot of projects where people just come back and say, we've been told to get a quote for an Ampetronic hearing loop, and there's no floor plans or any information about it. We're just told to kind of help people with a quote up. So if you come across jobs, this is a great tool to help you understand what sort of equipment you're dealing with and what sort of loop you need to do. Jacob, do you have a phased array that you could just show, so you can kind of show a difference of how that appears and showing the field strength and everything in regards to that? Or do you want to add another?
Yeah, no,
test?
I don't have one that I've currently designed, but I was planning on going through and showing that. So I'll go back into the company project. I'll go back into that space, and we're actually going to change that now to a phased array or a low loss of some type. So go back into my A-Field Design version 1. I'm going to go into my design tab when it finishes loading. And we can see I'm going to stick with all the same values that I had previously, just so you know, you guys have got a good comparison. So we've used a perimeter loop. I'm going to go with a loss control multi-loop. So I sometimes call this a phased array, but we start to see that we have two loops now that sort of have a figure eight or crisscrossing sort of motion to cover as much space as possible. Metal structures, so this now becomes quite important because you'd be using this if we had metal to make sure that the variation across the space isn't too large. So I'd hit metal structure. If I did use manual loss figure, I could input something that I got from my measure app, or I'm just going to go with concrete with moderate reinforcement. Now I know that that gives me a value of 4.9 dB of metal loss, which I can show you that in a bit. I've got my configuration here, optimize. Optimize basically is the best for large areas, and we'll make sure that the coverage is as smooth as possible. Non-overlap states over here, no overlap array minimizes conduit runs and costs, but with high variation across the area. So you can see how the segment, I think array 1 is the green one and array 2 is the red one. They don't actually overlap in terms of their cable runs, if that makes sense. If I did a no overlap, basically what that means is the red and green will have the same position along the X and the Y axis. Essentially, think about if you're cutting concrete to fit a massive phased array in, you don't want to have to cut long segments and multiple of them. So basically, we can do a non-overlap, and both arrays will basically sit on the same sort of segments, if that makes sense. We can also set a preferred segment width. So if for whatever reason the default that the system is outputting isn't good enough, we can minimize, make them smaller if we want. Leaving it to 0 just is the default, so it'll do whatever it needs to do. It doesn't mean that the segment widths are 0, it's just a default there. Cables and everything will still be the same, just to give you a control or comparison. So if I go to my output now, we can already see that it's changed. I've got array 1 and array 2. Let it figure itself out. There we go. So straight off the bat, we've had to go for a driver that has 2 outputs for obvious reasons, because we've got 2 arrays. But we've had to step it up a bit because we've got, up to 5 dB of metal loss now. Same as before, we can see all the information that we'd previously input. I'm gonna go straight over to my variation tab, and we can see how much this has changed straight off the bat, right? We've got our plot looking a little bit different. Our manual adjustment is still there, so I'm going to actually set that to 0. So we go down a bit. There we go. I'm actually going to go back to the input because I think I might have left. Yeah, I left no overlap on. So we can see that if I go back to my output there, how much variation I'm getting. This is actually a good indication because if I go to my loop layout, we can see how they're actually sitting right on top of each other, which is what I was trying to explain before. If I go back to my inputs and I change this to an optimized, in my output section, I'm going to see a very smooth result across the top here. Okay, I'm not going to see all this variation. As I said before, this is what I would use if I had metal loss. Even a small amount of metal in a building can affect, say, a perimeter loop, for example. So this is where I'm going to want to make sure I'm using a phased array.
And possibly also if you've got maybe meeting rooms that might be adjacent to each other, would this be a use case for that too?
Yeah, so in talking about overspill, we can start to look at our vertical adjacency. So this is our +6 and our -3. If we really needed to see what sort of overspill we're getting, so let's say in the vertical sense, I would set this maybe to 3 meters, because that would be where the next slab starts. So I'd hit enter, and we should actually see all of these plots change quite a bit, just as an example. Yeah, so we can see now I've actually set my I've set my height of my telecoil 3 meters above floor height, and we can see how much we're actually dropping down on that field strength. So yeah, as Chris said, that'd be for vertical adjacency or something like that. Just going to set that back to 1.2 just to give us a standard. And I'll take you through, we'll have one more quick look at the variation, and then we'll start to look at the loop layout, because that's where it starts to get a bit more important and a bit more, you need to be a bit more focused when reading the loop layout when it's a phased array or a loss control or a low spill or something like that.
And with a face array, does it help people if they had an image overlaid when you get to the loop layout side of things, just to give it an orientation?
Yeah, basically, even with a perimeter loop, I would say it's always good to have an image, just because the installer is going to thank you when they go to install it. It just makes it simpler to understand what they're looking at. So yeah, we can see our variation. One thing to note actually is how little overspill we're getting directly on the outsides. That's because of the way that the cables actually cross each other now, and they start to interact and cancel each other out. When we had a perimeter loop, it was only one cable and it didn't really didn't really interact with itself. Now that we've got multiple cables and they're snaking in multiple directions, they do start to play with each other. So we can see our overspill is good. And we can see it's changed. We've got a C5-2 driver because I dropped down that current level that I had before. We can see we can basically use any driver that has dual outputs on it now to cover that. The note sections are still the same. They don't change at all. So loop layout, we can see we're not overlapping anymore because I turned that option off back in the inputs tab. But as I scroll down, you can start to see this gets a little bit more involved here. Now, a lot of people do get confused about how to read this section, so I might just give a quick example. We're looking at array 1, and I can actually turn off the second array if I want to make it nice and easy to see. We're looking at array 1, and in terms of how far we go across the room, we know we're sitting in, what was it, 20 centimeters, 200 mil, and we're also sitting in 200 mil from this side. So when I start, I'm looking at the start and the finish. I can use the width values to double check later on, but I'm always reading the start and the finish. Okay, so we're looking along the y-axis, along the x-axis. So I'm at 0.2, which is there. Then I'm looking at 2.75, which is this segment or this line of the segment. Then I'm looking at 4.20, so you can see how I'm reading that number, then that, then that, then that, okay? Then we're looking at 6.75, 8.20, 10.75, 12.20, and 14.75, okay? And then I can do the same for array 2 if I like. We can see how many segments I've got. So I've got 3 segments. That's how you would go about reading this and actually installing it. So if I went back to array 1, what I would do in the real world is I would lay 2 tape measures down, okay? And then on either side of the room, I'd put my gaff down on the floor first, and I'd do a marking at each one of these points. And then when I go to snake the cable around, it's very easy to see when my lines are going to cross each other and where they don't cross each other and things like that. Yeah, always refer back to this page of the report. I'm just going to export the report as well without the plan view, just to show you guys how it shows up and how it's a little bit different than a perimeter loop, because someone that's installing this needs to really be able to understand how to read it.
Just while you're waiting on that, Phil has asked a question about the calculation time we're seeing on the software on the web GUI. Bearing in mind at the moment, Phil, that we're working from home and running the webinar, so I think Jacob's computer might be working a bit more overtime, and his internet connection, because he's running the webinar as well. But it's not an awful long time to wait for the calculations to happen, so it's generally a little bit quicker than that.
Yeah, I mean, it would be nice if there was an offline side of this so that everything was computing real time. But to be honest, I'm going to use that. I would rather have to wait for these to happen with a few seconds and have the online component so everything is backed up online. Makes it a lot easier in the future on me. But generally, when I'm at work in the office, I don't usually see times like this. So yeah, I think Chris has nailed it. It's probably running the webinar as well, maybe. If there's any other questions,
as well.
Yeah, true. If there's any other questions, feel free to shout them out. So I'm going to browse reports now. I'm going to go back so we can see, I believe this is the draft 2, so that's the one I've just done. I'm going to open this, I'm going to scroll down. Yeah, we can see that this is our phased array. And as I scroll down, you'll see it gives us an overview of both arrays on top of each other to show you a quick example, and then splits them up as well, because it would be pretty hard to try and build off of just this one alone. So I'm going to go back down to look at my array 1. I've got all the same values that I looked at before. My array 2, the same values that I looked at there before, and then my feed cable page there. So if I go back out, I can save that as if I want as my or issue it as my final design. But that's pretty much it in terms of running through a perimeter loop and a phased array as an example. I don't think, do we want to take any questions, Chris? Or
yeah, we do have another question from Chris. He said that after they do the design, do they send it off to Jands for cross-checking and order the equipment? So, do you want to talk to the unique IDs that Jands as the distributor has the ability to check as well?
Yeah, so I believe, obviously being in Jands, I haven't issued a design to get checked by Jands, but I believe what happens if I go into my design here, we can see I've got the issue design button down here, and then I've also got the issue design here. So I'll click that just to give you a quick example of what happens. It basically allows us to issue that as the main one out of all the drafts that we have, and then allows us to request approval. So for something similar like a perimeter loop, I don't believe we actually need a design, but as soon as don't quote me on that, but as soon as it comes to something like, a larger system, a phased array of some type, we would generally need to approve that, and we need to see the designs when it comes to purchasing and things like that. I'm not going to hit request approval because it'll probably go into our queue. In terms of larger systems where you may need some sort of CAD import, or you're working to a really large system where we've got multiple loops on the same system, that's something where Jands would design it. So we would approve it ourselves, and then we would give you the design proposal, and then we'd give you the design when you purchase the equipment. So it's essentially, you need to make sure that, or we need to make sure that a design is done correctly for the space and will work. Because I haven't really mentioned it yet, but when we think about the reason why we're doing this, yes, most people are just ticking a box and doing their job, but you got to think about the end user, right? This is actually serving a benefit for people that have a disability of some sort. So you got to think, we need to get this system right for the people that are using it. Yeah.
And also, I'll add on to that, Chris, that when it comes to ordering the equipment, even though this is the design side, you still just need to send a standard purchase order through to your account manager or the customer service team to actually order the equipment once it's all good. We don't order anything based off these designs. This is for the AET and the tech operations team to check. But it's also a really good tool to help show to your end clients that you've taken all this into account, particularly when it comes to new buildings where the standards have changed in the last couple of years and there's been a few revisions. You need to make sure that you can help show that you're meeting the coverage for the standards, and just real good peace of mind as well. It's a great tool to give peace of mind to your clients.
Yeah, just on that point there, if you go to the outputs tab and you're looking at like variations and things like that, and you're looking at maybe a competitor's design, it's really good to understand how Loopworks works, because you might be able to see how potentially it happens, right, in quoting and things like that, or consulting, that people might try and make a system look way better than what it really does look, right? Because something green on the screen might look a little bit better than something that's red, okay? We see it when it comes to like dispersion or SPL charts or something when you're looking at loudspeakers. So it's good to understand how to read this, so that if someone brings someone else's design to you, you can understand what's going on as well. Chris, did we have any other questions that came through at the beginning of the session?
No, that's it for now.
Cool. Okay. Yeah, if anyone has no more questions, I think we might end it there. As we said, it's being recorded, so you guys can grab it and show it to anyone else you want. If you do want more in depth or one-on-one, feel free to contact us. Chris and I can set something up. Or if you want to talk about loops in general, yeah.
Yeah, and for the rest of the Jands webinar series, feel free to sign up for anything you want. Check the Jands webinar page on our website as well. Also, we're promoting a lot of it through the social media channels like LinkedIn and Facebook. And thank you so much for joining us, everyone. We really appreciate the time you've taken, and we hope this has been actually helpful and informative. So thank you very much.
All right, see you guys later. Bye.